Morning guys. Today we're going to take a look at some algebraic examples for kites. So let's take a look together at page 19 and we're going to start off with example number 12. Now example number 12, again I apologize if my drawing is not great, okay? They give us a kite. They tell us that this angle right here is 5x plus 23 and they tell us that this over here is 8x minus 31. Let me double check and make sure I read those properly. Yes I did. Okay, and this right here is angle L, right? Okay, so recall the property of kites that we're going to need here. We need to remember that kites have one pair of opposite congruent angles, right? Opposite means across from, and it clearly can't be this pair because that's acute and that's obtuse, so that just wouldn't work. So if these two are equal or they're congruent, what equation do you think I would have to set up? Well, congruent means the same, and the same in Algebra 1 simply means equal. So I would set these two equal to each other. So my equation would be 5x plus 23 equals 8x minus 31. From here, let's be strategic about how we solve. I would prefer to get all the x's on the right by subtracting 5x, and the reason for that is I end up avoiding negatives, right? Add 31 to the other side, right? So I get, is it 54? Equals 3x, and divide both sides through by 3, and I think I get 18 equals x. Got to be careful though to make sure to read the problem. The problem says find the measure of angle L, not x. So what I'd have to do is take that x and substitute back in. So let's go do that. 5 times 18 plus 23, 5 times 18, 50, 40, make 90, plus 23, and I get 113 would be the measure of angle L. So that's one scenario you could see with a kite setting opposite congruent angles equal to each other and solving for a variable. Another scenario would be something like question number 13, where you may have to use n minus 2 times 180. And let me show what I mean by that. All right. So the one we're looking at now, guys, is example number 13. So they tell me this is 5x plus 14. This is 109, I think. Yeah, and that's 3x plus 8. Okay, first things first. One pair of opposite congruent angles, right? If this is 109, that's 109. Now, what I said about n minus 2 times 180, many of you guys actually won't need that because you simply remember how many degrees are inside a quadrilateral. How many degrees is that, guys? 360, right? So my equation here, in order to solve for x, would simply be combine all the like terms, add them all up, set them equal to 360. All right? So in that case, I would have 5x plus 14, yes, that is what it was, plus 3x plus 8 plus 109 plus 109 equals 360. Let's combine some like terms. 5x and 3x make 8x. Let's see, these two make 218. 14 and 8 make 22. And 218 plus 22 gives me 240. From here, it's actually a relatively simple two-step equation. Subtract 240 from both sides, and then divide both sides by 8. Let's see, that's 60 over 4, which is 30 over 2, which is 15 over 1. So x would simply be 15. So the first example we looked at, we simply set two things equal. This next example, we saw that we had to use the fact that there are 360 degrees inside a kite, and we had to use that in order to set up our equation. The next example is going to test something a little bit different, which is whether or not you know the properties of the diagonals of a kite and how they correspond to the triangle sum theorem. All right. So the last one we're going to take a look at for today is example number 14. Almost done, guys, I promise. I mean, I've been known to lie before, but in this case, I'm actually not. All right. So it's ruts. Huh, somebody has a sense of humor. Ruts and v. Okay, and they tell me that's 9x plus 1. And that's 23x minus 7. All right, guys. So the property that they're testing here is whether or not you know something important about the diagonals of a kite. The diagonals of a kite intersect at what angles? What kind of angles do they form? They form 90-degree angles, right? That's because they are perpendicular. Perpendicular means they intersect at 90-degree angles. That's interesting though. So I've used up in this triangle over here 90 degrees, right? How many degrees are left for these two? Well, if I've used up 90 and there were originally 180, I've only got 90 left, right? So my equation for this one would actually be add these two up and set them equal to 90. Let's combine some like terms. So that would be 32x, yeah, and then minus 6 equals 90. 32x equals 96, and if I divide both sides by 32, I think I should get that x equals 3. All right. Again, though, I got to be careful not to get too excited about that because that's not what they asked me for. They asked me for the measure of the angle STV, right? STV. So they want to know this one right here. Okay, which one of those two is the same as this one? It would be this one over here, right? Because these two triangles are the same, and so corresponding parts of congruent triangles are congruent. So all I would have to do to find the measure of this angle over here is substitute. When I substitute, I get 9 times 3 plus 1, is that right? Yeah. And so I get 27 plus 1, 28. Now, just a word, oh my god, I'm vlogging again. Just a word to the wise. Kites are not going to be heavily assessed on the geometry EOC, okay? The EOC is going to focus much more heavily on parallelograms, rectangles, rhombi, and squares, all right? There may be the occasional question about trapezoids, all right? And maybe the occasional question about kites, but they're not going to be the focus, all right? That being said, kites are actually pretty cool because they review a lot of concepts. In this particular case, the only thing about a kite we used was the fact that the diagonals were perpendicular. But what that did was it allowed us to use triangle sum theorem, right, in order to solve for an unknown and find the measures of the angles.